Alright, so we can actually start. Let's see who all we have. We have Arav, Advik, Dikshita, Gitesh, Hiranya, Lakshita, Pranav, Arihan, Tanu. Oh, Dikshita also got glasses like me? Okay. So, okay, let's get started. So, while we are waiting for everybody else, Vasundhara also is here. So Gitesh, to your point, if you have to find out if any number is divisible by 3 or 9, you just have to add them up, and the sum of the numbers, if that is divisible by 3 or 9, let's say if you are talking about 121. If you have to find out if this is divisible by 3, what you do is add them. 1 plus 2 plus 1. This is 4. Is 4 divisible by 3? No. So this number is not divisible by 3. Same thing applies for 9 also. If I have 1008, if I am trying to find out if this is divisible by 9, I have to just add all the numbers. 1 plus 8, 9. Is 9 divisible by 9? Yes. So this number will be divisible by 9. You can divide it and you can figure it out. So, and this applies only for 3 and 9. Don't do that same trick for other numbers. That would go wrong. Alright. So, yes, Advik.
And so is there other methods to find other numbers?
Yeah, there are other methods, but we're not talking about that right now. This was a question that came because Gitesh joined the class a little early and he heard me talking about those multiples and factors, so he just had a curious question. Okay. Alright. So what are you going to learn today in this class? We have Sanvita also. So we can actually get started now. So we are going to talk about probability and statistics. That is the next topic we wanted to pick up. No, I'll leave that job for your teacher. I have the questions in front of me. I have the topic in front of me. Okay. And make sure that you guys only talk when there's something that is actually helping you. Don't do my job. Don't make me redundant. Otherwise, what will the teacher do? Yeah. That's a request to everybody. So I will give you guys enough opportunity to talk, and that is where I need inputs from you. But try to talk when actually it's adding value, it's helping you learn something. Don't talk just because there's no prize. Okay, alright. So we will talk about statistics and probability, and we will start with introduction to probability, and then we'll talk about some sample problems, and then we will look at what is intuitive probability. So probability is one of my most favorite, and it is one of the most hated subject. Yeah. People say, if somebody says, would you get a good score? You say probably, and then don't like it. Nobody likes it. They want to hear, yes, I will get a very good score. And that is where you want the probability to be very high of getting a good score. And that's exactly what the literal meaning of probability is. A possibility of something to happen. That is what is probability. Now, that is the English part of it. If I am saying, what is the probability of rain? And then you can look at the weather forecast and say, okay, it says 40%. Meaning, 4 out of 10. If I had 10 chances, it might rain for 4. That's how you relate. But let's come back to little more meaningful examples of probability, and then we'll try to relate. Now, if anybody in the class says that I have never tossed a coin, that will be difficult to believe. So I'm sure everybody has seen that if you have a coin, on one side you have a head and the other side you have a tail. When you toss a coin, when you flip a coin, you don't know whether you will get a head or you might get a tail. If you toss it once, you have a 50-50 chance. Gitesh, take out your card. You have a 50-50 chance. But that doesn't mean that if you toss it once, you got a head, next time you'll get a tail. No, there's no guarantee. Okay? So every toss, every time you do a certain event, it just tells you what is the likelihood of something happening. out of the n number of chances. Now, let's look at this scenario when we're talking about tossing a coin, which has head on one side and tail on the other side. Am I going at the right pace, kids? Everybody okay with the speed at which I'm talking? Everybody can follow me? Okay. All right. So, and if I'm not, don't hesitate, stop me, okay? Hiranya, okay, beta? Sanita, okay? Okay, wonderful. Tanu, no problem? All right.
Yeah, no problem.
Okay, wonderful. So now let's come back to the situation when we are talking about tossing a coin. I had a coin, I tossed it. One side is head, one side is tail. So what are the total number of possibilities? It could be head or it could be tail. So total number of possibilities, total number of possibilities or outcome is 2, right? When I'm tossing a coin, I can get a head or I can get a tail. So there are total 2 options. One is head, one is tail. I said 2 options, I got 10 balloons. Okay, anyways, not needed. So, total 2 options, that is total number of possibilities. Now, what is the possibility of getting a head out of the 2? Yadvik.
1 in a 2 chance.
1 in a 2 chance. Sarvita saying the same thing?
Yeah.
Yeah. So that is what is called probability here. Here, the probability of getting a head is total number of chances you can get a head in one toss. You can maximum get 1 head, right? And how many total options you can get? You can get a head or you can get a tail. So you can, total number of options you can get is 2. So this is what is called probability. Number of occurrence, number of possibility, a number of chances of something to happen versus total number of chances. That is what is the definition of probability. So now let's say that in pure, simple, easy English one more time. So when you say probability in English says the number of occurrence of a certain event, number of occurrence of certain event or any criteria that you're talking about, event versus total number of possible events. I'm just making it up, okay? I'm just putting that in any easy way that you can relate. Saying probability is probability of certain thing, right? Let's say there are 10 kids in the class. What is the probability of me getting the first rank in the class? There are 10 kids. Everybody can get the first rank. Whoever studies well can get the first rank. So my probability of getting first rank is only 1. I am only one person. I will get the first rank only once. But there are total 10 kids. Anybody can get that. So my probability is 1 out of 10. Yeah? So this is the number of occurrence of a certain event by the total number of possible events. That is how, that will be our main premise of how you will look at probability going forward. So let's continue. Is this part clear so far?
Yes, sir.
Okay. Now, and I would request everybody to turn the videos on, because otherwise, I'll become a robot very soon. If I only see the screen with no faces to it, I'll end up becoming a non-existent person. All of you did not have to do that firecracker thing without anything being close to Diwali. Okay, let's come back to this one. So what I'm saying is, now let's look at some more examples. Now let's look at one game that I'm not sure if you guys got a chance to play much or not, but I would assume You guys have played because you guys are still babies. Not babies, right? You're kids. Okay? You would have seen something like a dice, right? Which has 6 sides to it. And whoever has learned cube, cuboid and right cylinder from me or elsewhere, you would know that, okay, this is a cube which has 6 sides. 6 sides. And every side has certain numbers written. So 1, 2, 3, 4, 5, 6. There are 6 sides. So every side has one unique number written to it, or number of dots. So this has 1 dot, meaning when this side comes up, you count that as 1. When this side comes up, you count that as 3. Let's say the bottom side has 2. When that side comes up, you read that as 2. Okay? So it's like when you roll a dice and one side comes up, and whatever number of dots you have there, that is your score or whatever you call it, right? So you would have used that for playing snake and ladder or for playing Ludo or other things, right? Where you roll a dice and you can get 1 out of 6 numbers, correct? So here, in case of a dice, if you roll the dice, you can get, these are the possible numbers that you can get. 1, 2, 3, 4, 5, 6. These are 6 options that you have, right? Is it okay for me to assume that everybody has seen how a dice is? Yeah? Everybody? Arihan, you don't sound confident? Yep. Okay. Nihan, have you seen how dice looks like? Yep. Okay. So the deal is this. I'm assuming that you guys are studying, but not compromising on your opportunity to play also. Okay. Don't grow up so fast that you only study and don't play. Make sure that whenever you get time to play, you play. Okay. Not video games. I'm talking about some physical games. So coming back to this one. If you're talking about a dice, it has 6 sides. It is nothing but a classic example of a cube which has 6 sides, and every side has certain dots engraved, and that is what we count as numbers. So you can have 1 dot, you can have 2 dots, you can have 3 dots, you can have 4 dots, you can have 5 dots, you can have 6 dots. A 1 out of the 6 numbers you will see being engraved on each side of the dice. Okay. So if you roll a dice, what is the possibility of you getting a 2? Yep. Yes or no?
1 and 6.
Okay. How about you, Rihan? What is your
1/6.
1/6? What is your point, Arav?
1/6.
Okay. So fine, I'm not giving chance to everybody else because everybody will say the same thing. I'll come back to you guys. I'll have interesting questions for you all. Okay. So again, as I said, probability of any number, let's say if I'm talking about 2, probability of getting 2 is always defined as the English part that I was talking about. What is the total number of possible events? I can get a 1, I can get a 2, I can get a 3, I can get a 4, I can get a 5, I can get a 6. So the total number of events that is possible is 6. And out of 6, the possibility of getting 2 is how many? Only 1. So probability is always number of events for the given scenario divided by total number of events. That is what is your probability always. Now let me tweak it and ask you the question. What is the probability of getting a number less than 2? Not out of this time, Sanvita.
1/6.
What is the probability of getting a number less than 4? Gitesh.
I think it's 4/6.
You did not hear the question clearly. I said, what is the probability of getting a number less than 4? Dikshita, you have to answer that.
3/6.
3/6. What is the probability of getting a number more than 4? That's a question for Pranav.
2/6.
2/6. Yep. What is the probability of getting a number greater than or equal to 3? That's a question for Let's see. I just want to make sure that everybody gets to speak. Hiranya? Hiranya, question for you, beta. So, I'll repeat my question. The question is, what is the probability of getting a number less than equal to 3? No? Hiranya still thinking? Okay, let me pick my second name. Let's say Thanu. Okay, no problem.
3/6.
3/6. I said 3 or less. Okay, so that means 3 or less. So these are the numbers which is less. I said 3 or less, meaning I'm including 3. So I have total 3. So when I'm saying probability of getting less than equal to 3, I'm including this, so this becomes 3/6. Yeah, you're right. Everybody is, yeah.
You said 3 or more.
I flipped the question. No, so again, I would not memorize it, right? So I just gave an example, and then no, I was checking, right? So when I picked up second name, I probably forgot what I had asked before, and Tanu answered that with the latest form of the question. Okay, so that's okay. Now let's pick up few interesting problems. Okay, so this is how you look at probability. Simple thing that you have to keep in mind is if you're talking about probability of a certain thing, you're talking about the chance of that particular scenario happening versus the total number of chance. That is what is your probability. Okay. So when we talked about what is the probability of one of the 10 students getting a first rank, obviously it's 1 out of 10. 9 other students can also get a first rank depending on how much they study or how good was their luck on the examination day. So likewise you can calculate. So let's pick up some legitimate questions. Okay, otherwise I will keep on giving you guys some questions that will probably not make much sense. So I'm picking up a question here, and if you guys, so Hiranya, I saw your message saying your mic is not working, so that's okay. As long as you're able to follow, it should be okay. Alright. So here I'm reading a question, and I would want you guys to give it a shot and tell me if there is something confusing. That is where I will jump in. Okay. So remember one thing, you will use tran but T method for solving it. If somebody doesn't remember, let me know. I have no reason to not bore you one more time. I'm reading the question for you guys. Just hear it carefully. The question is, we have a bag with 9 red marbles. We have a bag with 9 red marbles, 2 blue marbles and 3 green marbles in it. We have a bag with 9 red marbles, 2 blue marbles and 3 green marbles in it. What is the probability of randomly selecting a non-blue marble from the bag? Okay, if anybody is jumping to answer it quickly, I will not let you answer. I am okay hearing the same answer from all of you, but any quick answer but wrong answer is not going to be appreciated. I'm still not done with the R part of it. Just because the question is with me, I'm reading it one more time so that R is taken care. Then I will let you guys do A and N. We have a bag with 9 red marbles, 2 blue marbles and 3 green marbles in it. What is the probability of randomly selecting a non-blue marble from the bag? I'm assuming that everybody has heard 9 red, 2 blue and 3 green marbles. And the question is, what is the probability of randomly selecting a non-blue marbles? Now, let's see. Adam, what is your answer?
I got 6/7, or I got 12 by 14 as solution 6/7.
Okay, 12 by 14 you got. Okay, let's see what Sanvita got.
I got the same thing.
Who got something different? Yep. How much did you get, Advik?
I got 5 out of 14.
Okay. Okay. Anybody else who got anything different from what Advik, Arav, and rest of the guys said? Pranav, what was your value?
Same as all.
Same as Arav. 12 by 14. How about you, Dikshita?
I got 6 over 17.
6 over 17. Okay. How about you, Gitesh?
Can you repeat the question?
Oh. See, I repeated the question 4 times. That is why I was focusing on R. We have a bag with 9 red marbles, 2 blue marbles, and 3 green marbles in it. What is the probability of randomly selecting a non-blue marble from the bag? Okay. Yeah, Dikshita.
It's 6 over 7.
6 over 7. Okay. Okay. So that is nothing but same as this one. Okay. All
I
right.
changed my answer.
Anyways, whatever you have to do, you have done. And if you are correcting it now, also you know why you are changing it. So it's okay. I mean, anyways, I'm going to write, wipe it off for everybody. Yes or no? What did you get?
I got 6, 7.
6 by 7. 6 over 7. How about you, Lokshita? Hiranya, you
I
can.
got 6 over 7.
6 over 7. Hiranya, you can type in the text box if your mic is not working. Okay. And then Vasundhara, how about you, beta?
I got the same.
Same. Okay. So, Arihan, how about you?
Yeah, I got 12, 14.
I got the same, 12 by 14. Okay. So, this one was probably an easy one. Let me do it by myself also. Just to reconfirm if this is fine or not. We have a bag with 9 red marbles, 2 blue marbles, and 3 green marbles. What is the probability of randomly selecting a non-blue marble? Non-blue. See, I read this enough. Now I am here on the analysis page. So it says, okay, the bag has 9 red, 2 blue, and 3 green marbles. The question is, what is the probability of getting a non-blue marble? So basically we are saying, except this one, what is my probability? So I am talking about total number of, so probability of getting non-blue. So we have to find out the probability of getting anything but not blue. Okay, so now I know probability says the probability of an event is probability of whatever we are trying to do, non-blue event by all event. If I am just picking up one ball, one marble here, I have total 9 plus 2 plus 3, 14. Total 14 marbles I can pick. Now, non-blue when I am talking about excluding this one. That means I will take this and I will take this together. Anything that comes is non-blue. So 9 plus 3, 12 is my non-blue scenario. That means 6 by 7. That's what you guys got. And I also got the same thing. So you guys are also literate. Your teacher is also literate. We are good. Yeah? We are all safe like this. Gitesh, you are saying something?
Yeah, I was gonna say
the same thing? Same thing? Yeah. Right. So let's look at this next question. Next question is find. So everybody is clear about the first one, right? I've just picked a few questions. We'll just go through them because there is no new concept that we're going to learn as part of what we have to cover right now. And we will look at the things once we finish these sample questions, and then we'll go to the next concepts. Next one is find the probability of pulling a need to take out my glasses. Find the probability of pulling a yellow marble from a bag with 3 yellow, 2 red, 2 green and 1 blue. Find the probability of pulling a yellow marble from a bag with 3 yellow, 2 red, 2 green and 1 blue. Wonderful. This is a good one. No, this is not a good one. Okay. Yep. What is the answer?
Can you repeat it since I was gone?
I'm reading it one more time. What is that?
I got 3 by 8.
Slow down. There's a speed breaker ahead. Okay, so no, it's good that you're able to do it quickly, and I'm not discouraging you from that, but I'm saying in general, don't rush. It's okay. I'm reading the question still. Find the probability of pulling a yellow marble from a bag with 3 yellow, 2 red, 2 green and 1 blue. Advik, you got a question?
Can you say the colors again?
3 yellow, 2 red, 2 green, 1 blue.
Okay, thank you.
Huh?
Thank you.
Okay. What is the answer that you got? Arav, you said 3 by 8. How about you, Dikshita?
3 by 8, sir.
Tanu?
3 over 8.
Okay. Then Pranav?
3 over 8.
Gitesh?
3 over 8.
Sanvita?
3 over 8.
Lakshita?
3 over 8.
I'm desperately waiting for somebody to give me a different answer. Arihan?
3 over 8.
Nihan?
3 by 8.
Everybody is disappointing me so much. See, if you get the answer right, what will I do then? Okay, anyway, but yeah, good thing is everybody got the right answer. And this was not complicated, so I'm not going there. I would certainly want to instill some level of confidence in you all that if you do something which is easy, let's not waste a lot of energy on that one. Let's go to the next one.
I got a different answer.
What is that?
6 over 16.
Are you having a plan to waste everybody's time? Okay, now let's go to the next one. Next question is this. Okay, this one is done. Let's go to next one. Okay, you roll a fair 6-sided die. What is the probability of not getting a 3? This is a good one. You roll a die, a 6-sided die. What is the probability of not getting a 3? Okay, let's see what Sangeeta has to say.
I got 5 over 6.
Pranav?
5 over 6.
Anybody who got different number? Apart from 10 over 12? Yeah, everybody got 5 by 6?
Yes.
Okay, everybody. So, Vasundhara, you got 5 over 6? Nihan got same? Okay. Alright, so let's go to the next one. Now this one will need your this will test your patience and your ability to solve a word problem without denying this magic word, magic rule, not magic word. Okay. Omar ordered his sister a birthday card from a company that randomly selects a card from their inventory. So everybody hands down. I'm reading a new question. So, yeah, Pranav is probably standing in the front of the queue. without reading the question, beta. Okay. Everybody hands down, okay? So that once I finish the question, I will know who's ready. Okay. Omar ordered his sister a birthday card from a company that randomly selects a card from the inventory. The company has 21 total cards in inventory. 14 of those cards are birthday cards. What is the probability of a pick that it is not a birthday card? I'm reading it one more time. I'm not in a hurry, Arab. Omar ordered his sister a birthday card from a company that randomly selects a card from the inventory. The company has 21 total cards in inventory. 14 of those cards are birthday cards. What is the probability that the picked card is not a birthday card? Okay. I hope everybody heard the question enough and nobody would want me to read the question one more time. Let's see what Dikshita says. Yep. What is the answer? What is your answer, Dikshita?
7/21, sir.
7/21. How about you, Thanu?
1/3.
Okay. What about you, Pranav?
7/21.
What?
With you.
Okay. How about you, Arav?
7/21 reduced to a third.
Anybody who got different numbers?
No.
No. Lochita, same numbers? Diwali is after 8 months. Okay? Or maybe 7. Okay. So, yeah. Gitesh got the same answer. 1/3 or 7/21.
Yeah.
So this question did not have anything complicated, so I'm just rushing through it, okay? So let's go to next one. And this one will need or test your patience a little bit. Make sure that you are listening to it carefully. And I want everybody to listen to it carefully, okay? Dikshita, you are ahead in the queue? Okay. Alright, let's go to the next question. The question says, the probability of Jamie making money investing in bonds is 1/20. The probability of Jamie making money investing in bonds is 1/20. The probability of Jamie making money investing in stocks is 82%. Which of these events is more likely? There are 3 options given. So let me read the question first and then I'll write down the answers, the options. The probability of Jamie making money investing in bonds is 1/20. The probability of Jamie making money investing in stocks is 82%. Which of these events is more likely? Choose one answer. And there are 3 answers given, which I'm going to read and write also. First option is Jamie makes money investing in bonds. Second option is Jamie makes money investing in stocks. Third option is neither. Both events are equally likely. This is a perfect question where you guys can do debate with me or debate among yourself. So all the kids who enjoy debate, this is a golden opportunity. So let me read the question one more time and then we'll look at what are the options and why. The probability of Jamie making money investing in bonds is 1 by 20. So bonds is 1 by 20. The probability of Jamie making money investing in stock is 82%. Stocks is 82%. Which of the events is more likely? First one is Jamie making money investing in bonds. Jamie makes money investing in stocks. Third option is neither. Both events are equally likely. Now I want to hear which option you guys are leaning towards and some of you will have to explain why. Let's see, Arihan, which option? Just tell me the option first. I'll come to the why part later.
It's actually a trick question. Wait.
Okay.
Because the option says that, all of the options say that Jamie will make money.
Jamie makes money. No, it says Jamie makes money investing in bonds. Jamie makes money investing in stocks. Neither of the options because both events are equally likely.
I think it's actually no option, but not C. It's not A, it's not B, it's not C.
Okay.
Because B.
No, so for now, just tell me your option. I'll come to the why part a little later. Okay.
Okay, so if I had to choose one, I'd choose B.
You'll choose C.
No, B.
You'll choose B. Okay. How about you, Arif?
I think I choose B
Because I will come to debate is second part of the story. Okay. First part is just the answer. Okay. So I got 2 B's. Okay. How about you, Pranav?
I got B.
How about you, Dikshita?
B, sir.
How about you, Nihan?
B.
How about you, Sanvita, Nosundara?
B.
B. Both B.
Yeah.
You guys are choosing B because my name starts with a B. Okay. All right. Let's see what Tanu has to say. B. Hiranya B. See, you guys are all choosing B because your teacher's name starts with B. I'm going to change my name to Chandrachud from tomorrow. That's my uncle's name. And then you'll have to choose option C. Okay. How about you, Advik?
C.
B. How about you, Gitesh? B. I cannot hear you. You are mute.
Sir, so is it asking which one's a better option or is it asking which one makes money?
No. So the question was, which of the option is more likely?
Does that? I can't get.
Okay. So anyway, so
I think it's B because it makes more money.
okay. So all right. We'll come to the conclusion part. Lakshita, what is your answer? B.
B.
You guys like your teacher so much. Okay. Okay. All right. I'm just kidding. Nihan. Tomorrow, Monday? No, Monday, no class tomorrow. Okay. All right. So now let's come back to this question and understand everybody's point of view. And I will pick up the kids who talk less, okay, so that they get more opportunity to talk. Lakshita, can you explain me, beta, why you think it's B?
I think it's B because it's 82% is greater than 1/20.
Okay. All right, Sanvita, what is your point of view?
I think it's B because 1/20 is equal to 5% and 82% is greater than 5%.
Okay. Now, Rihan, you tell me, what is your point of view?
Well, since it's a multi-choice question, I would have to choose B because 82% is more than 5% because 1/20 is 0.05. And then if you count the 500, it's 5.
Okay.
But honestly, if I had the option to choose no answer, I would choose that because
Okay.
The question is asking which one's more likely, but all of the answers are saying this one 100% chance makes
No. It says, no, see, again, you have to read the question. I know where your dilemma is. You're saying, which is more likely? More likely is, there's no guarantee here. The question says, which of the below options are more likely? Jamie makes more money investing in bonds. Jamie makes more money in stocks. Neither of the options. So it is still not saying which one is correct.
bonds, and if it just said
Okay, hold it there. I'll have an better answer for you. Okay, just hold it there. Let's hear if Vasundhara has a way to explain. Arav, you'll not get a chance. You have already explained it, and you already talk. I'm just trying to give a little more chance to everybody else. Okay, so Vasundhara.
I think because if you convert 1 over 20 into that percentage, it's 5%, and then 82% it's greater than 5%.
Okay. Yeah. So I think everybody is giving me the similar answer, and none of them are wrong, except for the fact that I owe a better response to Arihan. So I'll come back to that. Now, if I have to solve this like a student, first thing I'll do is read the question one more time. Okay? And I have read it enough, but I'm still reading it because there's some dust that we have to clear. The probability of Jamie making money investing in bond is 1 by 20. So this is the probability of Jamie money making in bonds. The probability of Jamie making money in stocks is 82%. Which of these events is more likely? So, and then we have these three options. Which of these events? So, we are told that probability of Jamie making money in bonds is 1 by 20 and probability of Jamie making money in stocks is 82%. Now it says, which of the below events are more likely? So, it's likely. No, there is no guarantee. Probability is not about guarantee. Okay? Probability is one of the most vague things that you can think of. Meaning, nobody can commit to it. It is just talking about the possibility of something happening. Okay. Now, I will look at it in a more simpler way. What is probability? Probability is something happening versus total number of chance. So here I have given the probability already. So probability of Jamie making money in bonds is 1 by 20. So she has 1 out of 20 chance. Similarly, probability of Jamie making money in stocks is 82%. So she has 82 out of 100. That is what 82% means. 82 by 100. 82%. So now it says between the two probabilities that you see, what is more likely? And more likely is nothing but likely. Probability is all about likeliness. What has a better chance? What has a higher chance? That is what is probability. Here your chance is 1 out of 20. Here your chance is 82 out of 20. Is that a doubt still? Here you have a better chance. Why people buy certain stocks versus some other stocks? Because the stock where people think it has a higher probability of making money, that is where they invest. Same thing here, between bonds and stocks, she has this probability, that she has 1 out of 20 chance. So maybe if she buys bonds 20 times, she probably might get some money here in one chance. Here, 82%, meaning 82 out of 100 is her chance. So that means when we are talking about likelihood or higher probability, when you are talking about which is a more likely, meaning which has a higher probability, this has a higher probability without any second thought to it. That is why I will pick up this one. Because I am not doing a calculation right now. Right? I am told that this is my probability, this is my probability. My question also says which one has a higher probability. Obviously, stock has a higher probability. This one is talking about Jamie makes money investing in stocks because that has a higher probability. That is how I will relate. But let me hear if Arihan still has a point. Is it making sense or you are You're probably not convinced.
It makes sense, but I'm just saying that I feel like the question itself is wrong. I mean, not the question, but like the answer choices. Like, if it was just bonds and if it was just stocks, then it would make sense.
No, so see, that is why you have a caveat here. It says, which is more likely? Which is more likely? And then you have three options, okay? So it says, which is more likely, meaning which one has higher probability. Something being likely. It is likely going to rain today. That means I am positive about it. I see a higher chance. It says more likely, meaning more probable, which has a higher probability. And that is why I am leaning on this option, because that is what my question also says. Yeah? Everybody convinced? Do you think I was successful as a teacher to convince Arihan?
Yes.
Yeah? Okay. So, yeah, I mean, right now, this one is, these are simple examples. That's why we are probably making some assumptions. That's okay. We will come back to this. So, we looked at some of the questions. Now let's talk about some concepts, and we'll probably not go deep into it, but we'll just try understanding the conceptual part of it, and then in the coming class, like I mentioned, we'll talk about theoretical and experimental probability. Then we'll talk about stem and leaf plots. Then we'll talk about histograms. So leaf plot and histograms, these are more like a task related thing that we will do. But let's try understanding what do we mean by experimental and theoretical probability. What is your understanding of that? In the simplest form, okay, don't overburden yourself by going deep into the concepts. Yes, Pranav. Explain me in a simple form, because I am a 5-year-old right now.
Okay, so basically, experimental probability is when you have data to make a probability with, and theoretical is when you don't have any data. It's based on like the thing that we like dice rolls. What is a percentage of a dice roll one?
Okay. Any other interesting thought to teach your 5-year-old teacher right now? Yeah, get this.
I don't know what pressure, but I think experimental probability means like when you have like data instead of like just plain like
Calculated. Okay.
yeah.
Let's see what Dikshita has to say. Yeah, Dikshita.
And then,
I think experiment like probabilities like the data, like what we think of them.
Okay. Arav?
I think experimental probability is the probability of where data has to come in and where dependent variable takes on
Okay.
to
Sanvita.
be the future results.
Okay. Let's see what Sanvita has to say.
I think it's like how likely an event is to occur, like after someone already like tested it by doing it in real life.
Okay. So I think you guys are leading towards a similar point of view. I will not, because I'm a 5-year-old right now for next 10 minutes. So I'm not trying to act intelligent. I will act like a baby. And when I think like a baby, right, we all know when somebody says, okay, theoretical, meaning it only has theory. Let's say if I pick up a coin and I know that if I toss it, I'll get a head or a tail. Probability of getting a head is half of the probability of getting a tail. Half of the total probabilities. Similarly, probability of getting a tail is half of the total number of chances. So I did not do anything. I did not even bother to take a coin out and toss it and then see the results. I was just going with a mathematical understanding of things. And again, I know a 5-year-old would not have that level of understanding for sure, but I have to strike a balance, right? So that's why I am acting like a 5-year baby when I have to learn from you guys, and I am trying to act like a teacher when I have to explain that back to you. But yeah, mathematics, in terms of English, if you again think about it, theoretical is where it's only theory involved, where you are just applying concepts and finding out probability. Wherein when you are talking about experimental probability, you are actually doing that event. Let's say, take the example of tossing a coin. You tossed a coin and then say, okay, I tossed it once, I got a head. I tossed it one more time, I got a head. Next time I tossed it, I got a tail. I did 20 times or I did 50 times. Then I took an average. And then I said, okay, based on this, I have seen out of 50 occurrences, 23 times I got head, 27 times I got tail. So my probability of getting a head was 23 out of 50 and getting a tail was 27 out of 50. So this is my probability based on the experiments done, based on the data that we collected. So that's why, like you guys explained, experimental probability is where you are actually doing the real experiment, doing some sampling of data, and then based on that experiment and the data from the experiment, you are deriving your probability. That is called experimental probability at the concept level. When we go through this, probably we'll have more things that we'll unearth, we'll peel more onions and get into deeper into it. But this is the concept level thing that we want to start with. So if you're talking about experimental probability, that simply means that you have done some experiments, you have done some sampling of data, and based on that you have derived your probability. And again, when you're talking about sample probability or experiments, you're not talking about 2 times a coin being tossed. Probably people will toss it 100 times and then take the average, because one or small sample of data can get a little misleading. And that is why when you talk about experimental probability, you do it enough to make sure that you are not making a judgment with very small sample of data. Okay, you have to go for a bigger set of data so that your average don't get skewed. Okay, and theoretical probability is theoretical probability. Whatever we did in the class, that is theoretical probability. I never even showed you guys how a dice look like. I said, okay, a dice is a 6-sided cube which has numbers engraved on all the sides, and this is what you would have seen. Let's look at it mathematically. So that is called theoretical probability, where you apply theory, you apply the concepts, and then you derive the probability. Okay, and that, see, a classic example, okay, would be, let's say we take an example. Okay, I'll show you a comparison and then I'll let you guys go. Let's say you're talking about tossing a coin which has head on one side and tail on other side. If let's say you tossed it 50 times, out of 50 times, every time you got a head or a tail, right? And then you counted it. So let's say you got 24 times you got head and 26 times you got tail. I'm just making it up, okay? Based on the experiment, which I never did, but I'm saying this is my experimental data. And then there's a theoretical probability, which always says probability of getting a head is 1 out of 2. So my probability will always remain 1 by 2 or 0.5. Here in this case, when we did the experiment, and then we saw that 24 out of 26 is my probability for head, which is little less than, 24 out of 50 is my probability for getting head, and 26 out of 50 is my probability for getting a tail, based on my experiment. So here you see that my experimental probability is a little different. This guy is a little less than 0.5, this guy is a little more than 0.5. And this is based on 50 times I have tossed a coin. If I would have tossed it 1000 times, this could have been a little different. If I had tossed it only twice, it could have been different. Right? So you will see that the experimental probability may or may not have little different data compared to your theoretical probability, where this guy will be very stubborn like me, that it will have the same value always. Do you guys think I'm very stubborn? Yeah? Okay. I need to be sometimes as a teacher. Okay, stubborn with the concepts, okay? Not as a person. Alright, with that being said, I will let you guys go. Next class we'll talk about histogram, we'll talk about stem and leaf, we'll talk about theoretical and experimental probability in depth, and then if time permits we'll start talking about other parts of the statistics as well. Any questions, any doubt that you guys have before I let you guys go? No?
No.
No? Then enjoy the rest of your evening and have fun. Alright?